Chemistry. You know, it's been a long 9 months of stoichiometry, molarity labs, and finishing projects at 12:30 at night, but at the end of the day, I can say without a doubt that chemistry is the only class that I took for 9th period this year. But with the final just around the corner, I think a brisk recap of the year would be more than welcome. Chemistry is all around us. Every time you sit back with your freshly microwaved cinnamon Pop-Tart from the school store, bam, that's chemistry. Every time you walk into Mr. D's room and shiver because it's an ungodly 63 degrees Fahrenheit, bam, chemistry. Even doing something as simple as drinking a glass of lemonade is packed with chemistry stuff. But just what is that lemonade made out of? Well, it depends on who you ask. Democritus would tell you the glass was made of atoms. He argued that atoms were the same in material but different in shape and size. Some were pointy, some had hooks, you get the idea. Then Thomson came around in 1904 and did this. He won a Nobel Prize for this. Then Rutherford came along and used his gold foil experiment to prove the existence of a dense, positively charged core called a nucleus at the center of the atom. Then bam, Bohr comes along and says the negatively charged electrons orbit the nucleus at the center. Then bam, it's 1920. Here comes James Chadwick to change the game with the discovery of the neutron. All these factors eventually led up to the model we use today, but to grasp a deeper understanding, we have to analyze the moles of the substance. And trust me, if there's one thing I know about, it's moles. First, let's take a look at dilution. Dilution is a process in which the concentration of a liquid is lessened by adding a solvent to a solution. In most cases, the solvent is usually water and is added to a different liquid in order to produce a new product. For example, a glass of iced lemonade becomes more diluted as ice begins to melt in it. The ice is the solvent and the lemonade is the solute, or the liquid in which the solvent is added. The stock solution, or the original volume of the lemonade undiluted by the ice, waters down as time passes. Now on to my specialty, which is Avogadro's number. The number 6.02 times 10 to the 23rd represents the number of atoms per mole of an element. On the periodic table, an element's atomic mass is equivalent to the number of grams in 6.02 times 10 to the 23rd atoms of that given element. If the ice cube in your lemonade has 2 moles of water in it, then the number of atoms in that cube is 2 times Avogadro's number. But what if you're not given the moles? This is where mole conversion comes in. Say your mass of ice is 36 grams. In order to find your atoms, you simply divide by the molar mass of water, which is 18, and multiply your quotient by Avogadro's number to get the same product. Now, you might think that there's nothing scientific about the water in your lemonade, but you'd be wrong. Every solution has properties in relation to the periodic table of elements. The further you go down, the larger the atoms get. Since the electrons are farther away from the nucleus, this decreases the energy needed to remove an electron, or ionization energy. Once you make your way to the right side of the periodic table, the atoms will get smaller. This is due to an increase in protons without the electron cloud getting bigger. Due to the small size but a large amount of atoms, the atoms further right gain electrons quicker, and this is called electronegativity. The oxygen in H2O, for example, is actually much more reactive than you'd think due to its location on the table. And that's it. That's the entirety of this video. It's a really simple concept, and I hope this cleared everything up. Are you kidding me? Did you really think we wouldn't make a rap for this? I'm out. I'm out. I gotta orthodox. Avogadro's number means in multiple instances your number of atoms in just 1 mole of a substance. In dilution, your water is the solvent. You gon' need your volume if you're ever gonna solve it.
First atomic models with Democritus and Dalton. The plum pudding model came from my main homie Thomson. Soon enough, however, Thomson's theory would be foiled. Rutherford disproved it with his epic golden foil.
Go up to down, yeah. The CO decrease, yeah. And no electro, yeah. Negativity, yeah. And noble gases, yeah. Aren't too reactive, yeah. The least helium, yeah. The most is fluorine, yeah.
Periodic table, solids, liquids, also gases. Mole conversions, molarity, hydrochloric acids. I wish I could say that chem this year was just fantastic. That would be a lie though, man, cause I just barely passed it.